So the White Clay Creek watershed is one of the focus areas of the Brandywine-Christina cluster. It's about 2,100 acres, about almost 10 miles of stream. Most of the parcels are eased by our partner, the Brandywine Conservancy, and the Stroud Center is sort of located at the bottom. We built the initial idea for this work through DRWI, and when the Hurricane Sandy Resiliency Grant Program came available, we saw an opportunity to bring more funding to it and leverage DRWI funds, but also to expand the scope from a water quality focus to water quality and water quantity. So you can see our goals have some of the normal water quality ideals there. We sort of add in temperature and ultimately the return of wild brook trout, but we're also focused on flooding and increasing the base flow and improving the overall ecosystem resiliency in the stream. So this watershed has a lot of intact forested buffers and buffers that have been built over the year, but we added another 74 acres of 100-foot minimum riparian forest buffers to provide both that filtering functionality and the in-stream functions. And we embedded some research questions into those buffers, including establishing trees in invasives, thinking about how we deal with birds that drop seeds down the tube and give us vines that overtake our trees. You notice there's always a net on the top of a tree shelter, and basically that was to stop birds from going down in the tubes and dying and killing the trees. But those nets, when they're left with the tassel that you see there on the right, really can damage the trees. So we also experimented with trying to create a hole that would leave the tree out but also keep the birds out, and fortunately it worked. We created over 13,000 feet of these level lip spreaders, which are basically sort of an enclosed trench on the contour that captures overland flow, fills up, infiltrates that water, but when it fills, it releases it. And you can see just sort of the normal construction sequence. So we built these things in different sizes, in different landscape positions, with different construction techniques so that we could really measure the work that they're doing and know better how to use them going forward in restoration projects. We did a lot of work with conservation planning, manure management plans, and ag BMP implementation. There's over 17,000 feet of new or restored terraces went in place, about 1,000 feet of waterway. And basically, what we're finding is we can really manage that runoff and the infiltration on the farm fields. And it's sort of important to note that the plans aren't simply maps of where the BMPs are. They're really intended to be management tools for the farmers to both improve their productivity and manage their conservation needs on the farm. We also experimented with large woody debris placement to slow down the hydrology during storm events in the watershed, improve the in-stream habitat, and alter the channel shape. The picture here shows some naturally recruited large woody debris in White Clay Creek. Our placement focused really on oversized wood in undersized channels, in part to address municipal concerns about this wood moving downstream towards bridges. So we're probably overstating the hydraulic effects and understating the habitat opportunities by doing that. We included an 1.5 acres of floodplain wetland right along White Clay Creek. And while this is probably the least cost-effective of our practices in terms of water quality and water quantity modifications, it does bring the added values of that floodplain wetland. And basically, you can see where it sits right along the stream there. As the stream stages up during a storm event, it begins to fill. When it's full, it overflows on the downstream end, and then it holds that water and settles that sediment while providing the habitat that we expect from the wetland. So in terms of overall storage, the level lip spreaders in the wetlands alone store about 9,200 cubic meters, which is about a quarter of a 2-inch 24-hour storm. So it's a really significant amount of storage in this watershed, and that doesn't count the extra infiltration we're getting from the other BMPs. We tried to model this the best we could. We're certainly well set up and have a history of measuring these different factors in White Clay Creek. Our big problem to date has been that since we built the project, it hasn't rained. We really have no big storm events to sort of define how well this is working or whether we met our goals. We routinely monitor the fisheries. We look at the macroinvertebrates, so we should be well positioned in terms of stream ecosystem health and system resiliency to see the impacts of these changes as soon as it, really we get a little bit of time and some storm events. So what went wrong? Basically, we started this in an entirely separate watershed. One landowner controlled about 80% of the property. We put the monitoring in place, built about 36 acres of forest buffer, and he got cold feet for the rest of the project. So we did a presto change-o to the white clay, and we're able to make it happen there. The other thing that occurred really late in the process is that we realized that the landowners, in spite of being required to speak to Brandywine Conservancy about a lot of these details, weren't. So we sort of did an end around and conveyed all the details of this directly to the Conservancy. We still have ongoing work. We have some soil health and cover cropping research plots, and we're intending to move those farming practices out to the rest of the watershed to try to continue to improve infiltration and reduce pollution and quantity runoff. And I guess I'm done. Thank you.